All right. Good evening, ladies and gentlemen. Welcome to the Calgary Python Meetup and the joint PyData Meetup. So this is your host, Carson, and we also have the PyData host, Ben, there. At the bottom of this page, there's this Slack channel that you can join to either post questions or just mingle around socializing, or there will also be job posting there. So feel free to check it out. And thank our sponsorship, Timid. Now, let me pass it to Rich to give us an introduction to Timid.
Yeah, thanks, Carson. Yeah, I'm one of the co-organizers with Carson for the Python Meetup group. And my company, the company I work for, is called Teamit. And what we've been doing is building remote and semi-remote based teams in Calgary. So it's this idea that people are self-selecting teams are the highest performing dev groups, right? So you can all imagine if you could choose the top 5 people that you've worked with in the past you'd like to work with again. And what we've been doing is building these remote teams for primarily San Francisco-based companies. And some of the companies have moved offices to Calgary, and others stay entirely remote. So we've both, if anyone's interested, I can just leave my email if you're looking for some Python roles. We've got quite a bit on the go. So drop me a note or look me up on LinkedIn, but we've got some of the data science stuff on the go, and your typical Python dev, both perm and contract with, like I said, mostly San Fran based companies. So despite everything going on in the world, it's still a busy, I'm sure you're all getting pinged like crazy by recruiters still, but it's still a pretty busy job market for us. So yeah, feel free to reach out if you're interested.
Cool. All right. So the next one is the famous Pac-Man rule. So this is a rule where when you are standing as a group of people, always leave room for one person to join your group. So when everything is back to normal, when you are socializing in Meetup or anything, just make sure you follow this rule to always leave a room for one person to join you. This is a great socializing rule. Today's talk. So as usual, we will have 2 talks. The first one is PyData one. It's the real-time AI on the edge, licenses from Energy Toolbase by Anton and Jules. The second one would be from the PyYYC. The title is Python for Data Analysis using Pandas and Seaborn by Oscar. So here are a couple upcoming events. The first one is the local YYC DataCon event. It's been postponed to March, and the exact time is still to be determined. So keep an eye on it, and I will keep you guys posted. The Django Con US will be canceled this year, unfortunately. It's been there for like 12 years, but it's get canceled this year. However, the Europe and Australia ones are online this year, so feel free to check it out. Couple news. The first one is the last release for Python 2, which is 2.7.18, has been released. And if you are still on Python 2, just please make sure to migrate to Python 3. Python 3.9 beta 3 has been available for testing, and Django 3.1 beta 1 has been released. The last one is pretty important. Django security release issued. So the security issue was there's some caveat in the memcache key relations. If you are using memcache or like anything with Django, just please make sure your Django version is up to date. So here are the reading for the month. The first one is using wrappers to log in Python. So this article shows how to use wrappers and loggers to log every time you enter or exit a function for debugging and controlling in production. So this article shows a great way to write these functions. And then if you are on production, it enables you to find the bugs for like where inside the system. The second one is caching and scaling Django. So this article gives a detailed example on the code to show the importance of caching and ways to scale. And it also shows some best practice for how to code caching, like the naming conventions and stuff. So it's a pretty good introductory article. the last one is deploy your PyTorch model to production. So this article shows how to save and load PyTorch model at first, and then it demonstrates a couple ways to deploy it. So whether using Flask and Docker or using Clipper or Now to deploy models. So there are quite a few different ways to deploy model, and this article gives a really good introduction. At last, so again, the top two blue lines shows the link to the Alberta COVID stats and Canada COVID stats. And note that our next Python meetup will be September because we will have a short break in the summer. So we will cancel the July and August one. So hopefully all you guys have a great summer. We're always looking for presenters. Any topic and experience level in Python is welcome. Feel free to reach out to me or Rich about anything like collaboration or presentation. And thank you all. Let me pass it over to Ben, our PyData organizer.
Thanks, Carson. So I'll just try to keep this relatively quick so we can get into the good stuff from Anton, Jules, and Oscar. So just quickly, the big note coming out of the local Calgary data community is that we are creating a official not-for-profit organization, which is the PyYYC Data Society. So we're currently in the process of incorporating that. The big kind of flagship event that we're going to be running out of that, which you guys may have heard about, is the PyYYC Data Conference. So that was originally scheduled for, as Carson alluded to, scheduled for March 2020, or scheduled for September 2020. The COVID situation has caused us to delay that until March 2021, but thus far everyone's been very amenable to that change. We're currently looking for speakers and also still looking at a few sponsorship opportunities. So if you guys are interested in submitting an abstract, I just want to let everyone know that, kind of all skill levels are going to be welcome. We wanted to have a range of talks from, expert level, fine tuning, optimization, and your PyTorch models, all the way down to, here's how you build a linear regression and move from Excel to Python. So, we kind of want a wide range of things. So, data scientists, ML engineers, statisticians, students, technology managers, all of those people should be the kind of people who should be applying and submitting abstracts for the talk. So in the link to these slides that I posted in the chat, there are several ways that you can keep up to date about the PyYYC Data Society and the conference. So there's another Slack channel that you guys can get added to that's going to have, same thing, community job postings, introductions. It's kind of like the jumping point for all of the data society or the data events in the city. We also have a LinkedIn group that you can join. And as always, you can find upcoming events at the yycdata.ca website. And finally, just briefly for PyData, of course, we're always looking for speakers and presenters. If you have a side project, thesis, a success story, or a learning experience, reach out directly to me. Also looking for somebody to organize a few workshops. And so that's pretty all skill levels welcome. If you want to run a workshop, we can find some content that's going to fit with your skill level. And so it's a bit of a commitment, but we found so far that's been very worthwhile for anybody who wants to participate in that. And finally, I do need some help maintaining the PyYYC data website. And so I built that in Node React. There's potential to migrate our Node backend over to Python. So if anybody wants to get into some web development, then also reach out to me after this to help out with a real life development project. And so with that, I'm going to kick it over to Jules and Anton. Jules is a software engineer, and Anton is a data scientist they both work at Payson, so Energy Toolbase. And they have been working on they work in the IoT energy monitoring space. And so they actually deal with, deploying real-time software and AI solutions that have to run in the field on the edge device, which is, a very exciting and interesting area to be in right now, especially in the Alberta space. So with that, I'll hand it over to you guys.
Sorry to interrupt. Just want to have a quick announcement. For those who just joined us, I've shared a Python draw spreadsheet link in the chat. So if you want to draw for a free Python license, please put in your name in the link. And let me just share that again in the chat. So if you want, let's wait, all panelists and attendees. There we go. So if you want to participate in the draw for a free Python license, please come into this Google spreadsheet and type in your name. All right, sorry to interrupt.
All good. All right, let me figure out the screen sharing part. Okay, there we go. And I don't want to see the Zoom. All right, perfect. Thank you guys for the introduction. Can everybody hear me okay? It's all good?
Yeah.
All right, cool. Yeah, so we will provide essentially an intro to how we do machine learning on the edge. In real time, we won't go into too much detail given the limited time frame, but we'd certainly love to answer the questions afterwards. So, oh, nice. All right, as mentioned, my name is Anton. I did my undergrad back in Russia in physics, then moved to Canada to U of T to do my master's. I like biking, eating sushi, as well as hanging out with my sighthounds. And we also have Jules on the call as well. So Jules went to University of Calgary for both of his undergrad and graduate degrees, and he also loves snowboarding, drinking craft beers, and playing his favorite bass guitar. So Energy Toolbase is a company owned by Payson, and we have a total of 49 people over North America, with larger offices in Calgary, Houston, and Stewart, Florida. We also have a few satellite offices, including one several time zones away in Hawaii. So here's the map of where we installed and currently operate the energy management systems. As you see, they're reasonably well spread around North America with 2 sites in Alberta. Before we go into the description of what we actually do in those locations specifically, I'd like to start with a preamble. So my preamble is that the world is full of similarly structured data, specifically the sequences data. So here's an example from oil and gas. In oil and gas, you have a wireline log, which is really nothing but depth-ordered physical measurements. And the classic problem there is to determine the type of rock given a pattern of these measurements, at a certain depth. In other words, looking at these squiggles from this depth, tell me what kind of rock it reminds you of. And then another example from, let's say, wearables industry. We have smartwatches these days, and they're all equipped with accelerometers, which essentially measure time-ordered motion of your arm, right? Typical problem in that industry is to tell which phase or activity of sleep the bearer of the watch is in. And then, take another example, the audio records, which are simply time-ordered air pressure records. The typical problem there is to turn the essentially the waveform into the text. And those are the kind of algorithms that sort of allow you to order a bunch of hand sanitizer by just asking Alexa, Google, or Siri, or whatever you prefer. And then finally, an example from our own practice. So energy usage records. Our typical problem is essentially, here's the profile of usage up until this point. Can you tell me what happens in the next 24 hours? And why am I talking about this? Well, even though I mentioned completely different industries, it is interesting that methods to solve those problems are actually quite similar. And we happen to have people from different backgrounds, yet with just enough overlap of technical skills to speak to each other. We also benefit from Payson's expertise in deploying on the edge at scale. And I personally find that having access to the two is really important for continuous operation and improvement and doing that efficiently. So that brings me to the conversation of the actual problem we deal with. So imagine this situation. You have to do a lot of laundry. To power up your laundry, you would draw energy from the grid. And the utility company, they will charge you for it. You need to pay for that energy, and the utilities, they will happily take your money. And essentially all of your energy demand, which is, the said laundry plus other appliances you might be running, is therefore balanced by the supplied energy from the grid. And then in your turn, you might be certainly interested in reducing this recurrent payment, right? Your energy bill. So how can you do that? Well, there's multiple options available. So option number one, purchase a solar panel. The energy that will be provided by the sun will offset some of the grid energy requested, right? And will decrease the recurring payment, as well as will also decrease the carbon footprint of your business or your house. However, the unfortunate part is that you can't offset your bill in the nighttime or when there's no sun. So you wish you could store that excess sun energy for later use. Which brings us to the option number two, adding the battery. So now we can offset the grid energy even more, as well as accumulate the extra energy from the sun to use it later when there is, little sun, clouds, or if it's nighttime. And that makes Billy May and yourself happy. However, it's not the end of the story. Here's an interesting detail. The way energy priced in some places like Ontario, California, Massachusetts, or New York is based on the time of use. On this plot, on the y-axis, is essentially how much you pay per kilowatt hour used. On x-axis is the time of the day. So you can see that the energy is expensive during peak hours and is relatively cheap when we sleep. So that certainly encourages offloading some of your energy-hungry processes to the off-peak hours, as well as motivates arbitrage. So in this case, arbitrage is essentially doing this kind of offloading systematically and automatically. So therefore, we have an option number three, which is take a full advantage of the utility rates and perform arbitrage with the control system, also known as energy management system, or EMS for short. So what EMS will do is it will try in real time to predict what your usage is going to be like in the next 24 hours, and will optimize the battery and the PV usage to maximize your bill savings. And Bill makes happy now. So, okay, cool. So now we know roughly the general purpose of PV and the battery stack. However, how do we pick the right size of the battery and the PV solar array? And the reality is that one of the main factors is actually how much energy a site, which is a house or a laundromat in our previous example, normally uses to begin with. If we have a small baby laundry like the one in the picture that is powered by few watts or kilowatts, it would likely need a small battery and a small PV array. However, if you happen to have a whole laundromat of heavy-duty machines, they might require a slightly bigger system. Other factors obviously include location, and location affects the weather and, as a consequence, the expected PV generation, right? So if the weather is usually cloudy in Moscow, you shouldn't expect too much PV. Location also affects the time of use profile. So the definition of the peak and an off-peak hours, the one that we talked about earlier, it actually varies across different states. And then there's also another factor, which is the predictability of the load. If the load is difficult to predict, you actually might want to increase the size of the battery. And an analogy here is actually similar to buying the booze for a big party. Imagine a party where your friends said that they might bring some other friends along, but you don't know how many. Therefore, you'd certainly want to buy more booze in case a whole army of people shows up at your porch. So what is ETB's role? this whole example. So essentially what we do is we provide an end-to-end solution through essentially 3 products. So first we have an energy tool-based web application that allows modeling and evaluation of solar and storage project proposals, which as an example of that being essentially picking the right system, the right size system. For those lucky ones that moved from pre-install into install/post-install phase, we provide the intelligent EMS, aka control system, that will actively manage and optimize the use of the PV and the battery to achieve the discussed energy bill savings. And for those really lucky ones with the control system deployed and running, we actually have Energy Data Hub that provides a glimpse into your deployed control system performance through a set of interactive dashboards and reports. All right, that's pretty cool. So now I'll briefly cover how we interact within the engineering team. So the ETB engineering team has 19 people, and those 19 people are broken into 3 teams essentially. The web platform team, the control system team, and the data science team. Each team has essentially a direct responsibility for their part of the product, as well as shared responsibility for the product overall. And that strongly motivates us not only win together, but also actually test together, making sure that all the components of the product play together nicely and provide the overall product integrity. So what does that mean for the data science team? Well, that actually means quite a bit. So first of all, it means that we're not there for support only, but we actually have a distinct component of a product to improve and maintain. And that also means we can't, spend time doing research only, though that is certainly part of the work. That also means, that's probably the biggest part, is that we can't really be sloppy with the code because there is no translate to nice code type of person between data science and control systems team, or between data science and the web platform team. Also, as a consequence, if there is a chance to optimize, we kind of have to, because the production system, the control systems, they actually have constraints that Jules will talk later.
Hey, Anton, we got a question actually.
Sure.
So utilities are in the business of selling power. Is there reluctance from utilities to get into buying electricity from consumers, or is there a benefit for them to sell this excess power to other customers in the grid?
All right, that is a pretty open question, I would say. Let's talk about it at the end of the presentation, because I can just go way too far.
Sounds good.
And I actually don't even know if I can, because I would have to focus it a little bit on the formulation. So let's just talk about it at the end of the presentation, if that's all right.
For sure.
All right, cool. So now I'm going to talk about the data science specific tasks at the ETB. So our main task is actually to provide a best possible guess, which we call a forecast, on what a site load over time might look like in the future, day ahead specifically. So essentially, we also need to update that forecast as the time goes. So basically, as the time goes, we need to do the forecast on a rolling basis so that the control system strategy could be updated. Our control system wants that forecast at 15 minutes interval for the next 24 hours. Therefore, at every single call to the forecaster has to provide a 96 points sequence as the forecast output. So depending on the product, the purpose of the forecast is actually quite different. So if we're talking about the web platform, the forecast there is used to mainly simulate the system kind of as deployed, field-like, during the user session. Hence, we have to really optimize our forecaster for the time and memory, because the user doesn't have forever to wait for their savings results, right? If we're talking about a control system, forecast there is obviously needed, well, obvious to me. Forecast there is needed mainly as a basis for taking action. And we actually call that a tactical forecast. So essentially, we need to optimize this forecast for mainly memory, because the computer in the field actually has RAM constraints. And again, Jules will talk a little bit about it later. And then finally, we have a monitor, which allows us to continuously monitor our performance, how our machine learning models are doing in the field, and also inform our R&D and model improvement strategies. So what drives a good forecast? You know, a good forecast is usually a combination of weather, data, and load. And we use things like the next 24 hours weather forecast. We also use things like trends in the load, you know, the volatility, and what's been happening with the load in the last, let's say, 7 days. It also helps to know what hour of the day of the week we're predicting for, and whether that's a holiday or not. How do we produce the forecast? In simple words, we first gather the load data and the site information, as in where the site is going to be located. That usually comes through the web platform. Then we train the models and validate their results. So that usually happens either in the cloud or in our cluster. If it's a web platform, it usually happens in the cloud as the user session proceeds. And then we deploy, when we're ready, we deploy or essentially expose our simulations to the forecast. And that happens either at the control system or at the web platform. So since this presentation is a bit more edge focused, I won't talk too much about the workflow pre-install, but I will talk about the workflow post-install a little bit. So, you know, we have a contract, we have a site that is getting their PV and battery set up. What does data science team need to do? So at this point, we need to essentially flex our brains and try to train the best model possible for the deployed site, given its data. So, you know, we optimize the model parameters, features, do some sort of assembling if we need to, and then we we version, tag, and deploy the models. And instead of, you know, going and drinking champagne, we actually look for the drift in the error of the models, and we try to retrain the model either periodically or when the error metrics essentially drift beyond the expected thresholds. And this is kind of the time when the data science team interacts really closely with the control systems team, because, you know, after all, the ML engine is a part of their system. So here are the few tools that we use. You might recognize a bunch of them. So we use Python and PyCharm for development, heavily rely on scikit-learn and Pandas as well. Then we mainly use Streamlit and Jupyter for, you know, demos, reporting, and that kind of stuff. We use Grafana for production dashboards, InfluxDB for storing time series data, and then CircleCI Docker, a bundle for integrity testing and deployment of both ML models and the control system things. We also rely heavily on Slack for communication within the team, as well as with our robot team members.
Hey, Anton.
Hey, yeah.
Do you prefer questions now or at the end?
At the end, because Jules is still has something to talk about. Okay, cool. So yeah, so here's the example, you know, of Slack communication between myself and my bot that tells me, hey, your package actually passed all the tests and successfully compiled and everything went well. So I'm happy, and therefore I see a happy GIF. So now I want to pass it over to Jules, who's going to talk about the kind of the architecture of our edge systems.
Yeah, thanks, Anton. And seeing a couple questions come in. These are great questions. Thanks for those. We'll hit them up after the presentation. For now, I want to zoom in a little bit and talk about how the control system is architected. So coming back to our laundry example, we showed that the Intelligent Energy Management System, the IEMS, is on-site and in direct communication with the battery storage devices and meters. We simply call it the site controller, to make things easy. There it is there in the little brain. The site controller is a small, ruggedized, fanless Linux box. Our software components are containerized and managed using Docker and Docker Compose. We store our container images in AWS's Elastic Container Registry. Configuration of the site is done using various .env and .json files that are mapped into containers using Docker's concept of volumes. We manage these configuration files redundantly with both Git and AWS S3 buckets. While it's all well and good to have a control system working away on site, nobody would believe that our system actually does its job unless we can point to an online dashboard with metrics of the site performance. So we use AWS's IoT core to ferry MQTT messages to the cloud, where they're processed in various different ways. Some information is headed for Energy Data Hub, our customer-facing monitoring product, and other information is used purely for engineering support tooling. The most basic example of one of our engineering tools that we use to keep an eye on sites is Slack. We use a webhook that puts warnings and more extreme log messages into dedicated Slack channels organized per site location. This isn't the only alerting mechanism we have in play by far, but it's certainly the one I interact with most regularly. We're also using other tools to keep watch on system resource usage and stay proactive to avoid resource exhaustion events. Those are terrible. So let's talk about what's going on inside the site controller itself. I had hinted that we have multiple containerized system components in play, and I want to give you folks a high-level overview of what they are and what they do. So our system uses a service-oriented architecture with varying levels of microness. You know, microservices are the hot thing right now. We're kind of pragmatic about it. So for those of you that may not be familiar with this idea, I'm going to use the idea of goblins to illustrate. So imagine you have to build a house, and you live in a world with goblins and trolls and stuff, and you can either hire a massive troll, which is very big, very strong, has tons of arms, and knows everything about how to build a house, or you can hire a bunch of little goblins, which are puny in comparison, only have 2 arms, and each one only knows about their own role in the house build. You wouldn't send the plumbing goblin to go frame the walls, for example. But the advantage of hiring all the little tiny goblins is that if one of your goblins gets sick or kidnapped by angry townspeople, the whole project doesn't come to a grinding halt. While the majority of your other goblins are working away, swinging hammers and turning screwdrivers, you can go find a new goblin that's good at plumbing, and the other ones keep working, slide the new goblin right in. So you can imagine that our IEMS has about 5-ish goblins. The first one is the Oracle Goblin. This goblin makes the predictions about how the site load is going to look in the future. Then we have the Modbus Gateway Goblin. This goblin is like the United Nations translator of goblins. It can translate IEMS commands into Modbus frames so we can talk to the physical devices on site. This one, we've smashed a bunch of goblins together into one for convenience. I'll just call him the device goblin, but for battery, inverter, or meter service, these goblins pretend to be those physical devices, so they have a representation in our system. Next, we've got the AWS IoT Bridge Goblin that will take anything you give it and repeat it so loud that the goblins in the cloud can hear. And finally, we have Batman. While some goblins just want to watch the world burn, Batman is working in the shadows to maintain order. It's not the goblin we deserve, but Batman is the goblin we need. Batman lives to manage batteries. That's why I called him Batman. And Batman is the locus of the intelligence of our system. Batman makes the call when to charge or discharge the batteries, for example. Now, Batman and the other goblins need a way to work together. To that end, we've given them two main ways to interact. The first is a message bus. The kind of star thing in the center is kind of common to all of them. And we use the MQTT messaging protocol. Any goblin can put messages on this bus and read any of the messages flying around. For example, a device goblin might ask the Modbus goblin to get the battery state of charge. The Modbus goblin will do so and put the result on the bus. The device goblin will have its information, but the AWS goblin is also listening and will throw that message up into the cloud for off-site tools to pick up and use. The second way our goblins communicate is through RESTful API endpoints. These are used in cases where one of them needs to very specifically interact with another. For instance, the Batman goblin might command a device goblin to start charging the batteries through an API call. These little services, they're all built in a pretty familiar stack, you know, Docker, Python, Flask, sometimes Fast API. Mosquito MQTT is running to glue them all together, and InfluxDB is also present to hold our time series data. So that was a lot about little goblins. Let's put them aside for a minute and talk about how we actually, you know, make these services. So we, like most, are taking advantage of the deployment automation made possible through Git and CI servers. Our process starts with writing version-controlled software. We use Git, we make branches, we do code reviews, we merge pull requests, standard stuff. Every time we push a commit, we trigger a build on Circle CI. Circle takes our source, compiles Docker images, runs our test suites. If all that goes well, Circle will then tag the images based on the Git branch and push them up to AWS ECR. Once in the Elastic Container Registry, they can be pulled down to site controllers and used immediately. That's how we do our updates. When the data science team creates a new forecast model for a site, the workflow is like fairly similar. They'll start with code, describing the model they wish to use. Then they move on to training the model, validate its performance. Once the model is ready to go to work in the real world, the team pushes that model to an AWS S3 bucket, not far away from the other site configuration file stored in S3. Remember, I mentioned we use .env and .json config files for every, the particular configuration for every site. This is right beside those. So these models can be pulled down to the test sites to effect an upgrade to the control system. So to give you an idea of what these actually look like in the real world, here's an example of an ESS energy storage system being installed in Edmonton. That big white box is a product by a Calgary-based company called Iguana. It's like iguana, but with an E at the start. It contains batteries, a BMS, that's a thing that handles like cell balancing and safety limiting and whatnot, and inverters to make the energy in the batteries available as AC power. Our site controller, it's that kind of big blocky gray thing that just looks like a heat sink, is installed in the cabinet with the other devices, and it's just that tiny box with a bunch of I/O on it. On the left, near the bottom, you can kind of see two serial ports, serial COM ports. These are connected to the inverters and BMS hardware, so our Modbus Goblin can talk to those. On the right are two Ethernet connections. One connects the IEMS to the internet, while the other is a LAN port we provide, so we can share the internet connection with other devices or communicate with them if they support TCP/IP. Let's see. Yeah, here we go. Here's kind of a clear view of the unit. You can see 6 LG Chem battery modules on the left. They've got those pretty lights, and 3 inverters on the right because it's 3-phase, and 4 glorious nerds surrounding it. On the far left is one of our engineering managers, Prudvi. On the far right is one of our senior developers, James, and the other 2 folks are, beside Prudvi is Kevin from Iguana. So before I wrap up, I just want to quickly shout out some of the biggest thorns in our sides. We wouldn't be the team we are today if it weren't for them. So without further ado, here's some greatest hits challenges that we deal with. So first up is third-party hardware. Each site to date has been its own little special snowflake. We're constantly integrating inverter and battery systems that we've never seen before. And every site has a different configuration due to its size, its load profile, and its rate tariffs based on where it is on Earth. Secondly, the grid. Sometimes it goes down, sometimes voltages fluctuate, sometimes truck drivers don't check their clearances when driving down your alleyway and manage to take out your power and your internet. That's great, not bitter or anything. Our next one is connectivity. Some of our sites are remote and rely on LTE connection to handle our telemetry. LTE's throughput is far more variable than wired connections, and that can pose a challenge for us, as like we strive to have the system feel as real-time as possible for our customers. Next, this one has affected us all in different ways. We've noticed the demand on a couple of our sites with load profiles that are driven mainly by human activity flattened out as employees switch to working from home. Their load profiles kind of look like an eternity of Saturdays instead of having this weekday, weekend cycle. Everyone's working remotely. Thanks to our monitoring tools, we noticed this very quickly and got to work adjusting our forecasting approach for these sites. Other sites with more automated industrial load profiles weren't nearly affected in the same way. Sometimes behavioral shifts don't have to be on a global scale to have an effect. We had a site where the site owner bought a Tesla and started charging it at work. The charging event demand was large enough that our system underperformed for a day or two, since it didn't expect these peaks to show up the way that they did. We didn't know a car was coming. These sorts of behavioral changes on site can cause us to go back and retrain models or sometimes rethink our strategy altogether. The goal here is obviously resilience. And the last one I'll mention is resource constraints. If any of you have worked in control systems before, then I'm sure you're very aware of how resource exhaustion can have disastrous ends. While our little fanless computers are nothing to scoff at, they're still quite humble machines. And we've got control loops running in a non-real-time environment. As we add new features that take up CPU cycles and memory space, we've got to constantly watch to make sure that they aren't stepping on Batman's toes. So that's it for us. Thanks for listening, guys. Let's hop in on some of these questions.
Yeah. So and we're gonna hold this question to about 5 minutes, so that we have enough time for Oscar afterwards, and then we'll circle back to anybody who wants to come back to answer a bit more questions. We'll circle back at the end. So why don't this first one, I'm sure, is directed to Anton. And so he's wondering like how you actually guys go about evaluating the forecast accuracy and updating it. So I'm not sure, I think you can see it, but he's wondering, are you using Bayesian updates to the forecast? Are you periodically updating it? How often is the edge model updated? If you could just kind of speak to those, I think that'd be pretty interesting.
Yeah. Okay. Cool. Yeah. I actually see the questions too.
Okay.
I'm just trying to hold on to my house because Inglewood's being pummeled right now with, I don't know, apocalypse outside of some sorts. So with all that hail being ignored, so we essentially update the forecast on a rolling basis. So I would say it's been essentially periodic updating. So yeah, every 15 minutes, new data comes in. So we produce the next set of forecasts. But also, as time passes, the control system needs to know what to do next. So that's kind of why the update is done essentially on a rolling time basis. With respect to model updates, we're essentially trying to kind of move away from the idea that we should really look at the drift of the models necessarily, every day and every minute, for a couple of reasons. So one reason is, surely you'll see the drift, but how do you decide, the threshold when you think the drift has gone too far? And that's kind of one of the main reasons why you potentially want to update your model sort of, weekly or daily or however else. There's also another trick that we try to do is using sort of model switching. So essentially, we have a couple models running at the same time, and some of them are complicated, some of them are simple, and we try to see which one produces consistently, higher error, and then we try to switch it with the one that produces a lower error at the time. So, for example, the situations like with COVID are easier to cache that way because, if you have a naive model running in the background as well as some complicated model that never seen COVID before, obviously at some point in the COVID, 3, 4 days, 5 days after lockdown, the naive model will start outperforming the complicated model because the complicated model hasn't seen that. And so you'd have to, take some time and figure out how to actually retrain them smartly. So that's like one thing. And then, essentially Alistair, he kind of, he's talking about the same thing in his second post about
So Anton, what kind of objective measurements do you use to determine when to affect a model change?
Sorry, say it again?
What do you have any like objective measurements that you use whenever you're to make a decision to affect a model change? Like, is there any metric that you're specifically measuring and you have a system set up, like Bayesian updating or anything like that? Is it kind of ad hoc? Like, how are you making that decision for when to affect a model switch?
That would be essentially the again, like tracking the error and seeing the cumulative error over a certain period of time in a rolling window basis. So, for example, we don't care whether this model was right or wrong like half a year ago, but what we do care is between the two models, who has been producing better results in the past, let's say 3 weeks or 2 weeks, that kind of stuff.
Cool.
There's a question about utilities. Do we have time to answer that one?
I mean, we probably, I don't know. Do we have time, Ben?
You can quickly, I would say we can actually disclose those numbers. It can reduce the cost quite a bit for some of the sites. It really depends on the geography. And again, we mainly operate outside of Canada, I would say. And there are some of the incentives in some of the states that actually decrease the bill like really significantly, but I can't talk to the specific numbers. Cool. And then so there's actually, I also have a question for Jules that I'll ask at the end. I'll actually post it to the panelists, and we're going to move on for now because Emmanuel also has a question. Jules, just to put it in your mind, I'm actually curious about what the impacts of at least once delivery using through MQQT is for the IoT devices and how you guys handle any duplicate messages. So I'll post that, and then you can maybe answer it at the end of the presentation. But for now, I think we should move on and let Oscar have his turn in the sun.
Yeah, and I'll answer via text if people add more questions in the Zoom Q&A.
Yeah, I can do that too if you guys want to ask more questions. But it's all within, reason as to how much we can answer. Yeah.
Also, guys, you can type the answers. So on the QA, if you open up the QA, and if you see the question, you can click type answers and just type the answers. And for those who are asking questions in the chat, you can also ask in the QA, so it's a little bit easier to manage. All right, so Oscar, are you ready?
Yeah, so hi everyone, my name is Oscar, and my talk is going to be about using Python for data analysis using Pandas and Seaborn. So can everyone hear me okay?
Yep.
Yep.
Okay. So just a bit about me. My background is in civil engineering, and I'm currently a construction project manager. So I manage commercial construction projects. So I'm not a data scientist. I don't really work in a data related role, but I started learning data science and machine learning because I think it's pretty useful and it will really help you in your work. So even if you don't work in a data role, it's a good skill to have, and you can do a lot of things with it. But yeah, I am interested in transitioning to a data related role. So if anyone in the audience is looking for a data science intern or junior data science, I'd like to chat with you. But anyways, so yeah, right now I'm learning more about artificial intelligence as well. So I'm taking the deep learning nano degree with Udacity. And also I am part of the Data for Good team, and I do community engagement. So if you guys have heard of the group, then I guess I'm doing my job right. But yeah, we also have a micro datathon that we're presenting on tomorrow. So if anyone's interested, you can check out the group for more details. Okay, so I'm gonna be showing a tutorial about how to get started with Pandas and Seaborn. So it's geared more towards beginners and people who might not even have experience using it. But I think it's a good way to get started, and hopefully at the end of this, you guys can take some of the skills I'm showing you to explore some data on your own and yeah, get going on your own projects. So I'm using Jupyter Notebooks. So if you guys don't have it set up or have the system, you can go to Anaconda, the website, and download. So Jupyter Notebooks comes with Anaconda. And there's a lot of tutorials you can use to kind of get set up. So you guys can Google it and get started. Okay, just a little brief thing on what Pandas and Seaborn is. So Pandas is a Python library for data manipulation and analysis. It allows for fast analysis, data cleaning, and preparation. So once you have Anaconda downloaded and you want to install Pandas on your system, you can either go to the Anaconda terminal or your command line and type in the following commands. And for Seaborn is a Python library for data visualization and statistical plotting. Works very well with Pandas and data frame objects. So you can do these commands to install Seaborn on your system. Okay, so I'm just gonna go to my notebook here. Okay, everyone can see the notebook.
Yep.
So okay, so yeah, if you have Jupyter Notebook set up, you can maybe follow along with me. If not, we'll be distributing this out to everyone so you guys can check it out later. So yeah, this is a basic tutorial on how to get started with Pandas and Seaborn. So first I'm going to show you about data frames. Data frame is a two-dimensional data structure where the data is aligned in labeled axes. So first I'm going to run the first cell. So yeah, you have to import Pandas and NumPy into your system. So just a brief about what NumPy is. It lets you work with arrays and it's used with Pandas a lot. Okay, so yeah, so here I'm going to create a data frame and show you more about different ways to create a data frame later down the road. But I'm using NumPys to create some random values for the data frame. So here from NumPy import random. And then I'm going to create a data frame using random numbers with 5 rows, 4 columns, and call indexes these names and columns W, X, Y, Z. And so let's take a look at what kind of data frame we can create. So yeah, these values are all random numbers that are generated from the NumPy rand-n with the row indexes and the column names. So when we have our data frame, we can use Pandas to kind of select different values. So here, if I specify my data frame with the W column, you can see all the values of W, or you can even show multiple columns together. This. So, and yeah, if you want to create your own column, you can specify it in these brackets. So I'm calling a new column with that has the values of the sum of W and X columns. So yeah, so here we can see what that looks like. So here I have a new column here with the sums of W and X. So these are the sums of the W and X column. And if we wanted to remove that column, we can use .drop and specify the name of the columns. And here I've put access equals 1. So that what that tells us is that we're doing this on the column side. If you didn't put any access or you put access equals 0, then it'll tell that we'll be updating the rows. So here, let's see what it looks like. So yeah, the new column is gone now. But if I show the data frame again, you'll see that the new column is still here. So that's because we have to do this other argument, in place equals true, to kind of specify that we actually want the data to be modified in place and the data frame to be updated. Because if you don't specify anything and in place equals false, then the operation is just performed and returns a copy. So when we do that and then show the data frame, okay, so there now it's actually gone. And like I mentioned earlier, you can, if you do access equals 0, then you can work with the rows. So I can drop the E row. So you can see that's gone. And if you wanted to select a specific row, you can use the .loc function. And so loc stands for location, and it takes in a label. So here I'm putting the label A, so row A into here, and it shows all the values for the row A. Or you can try doing iloc, which takes in an index. So so if I put 2, then it'll give me the C row. So you can kind of see here that gives me all the values of index 2, which is row C. And you can also do a subset of using loc. So here I'm specifying B and Y. So I get the value on row B and column Y. So yeah, so that matches. And I can do it more specifically as well. Row A, row B, where it is column W and X. So yeah, so these, let's see if it matches. And yeah, so it does. So yeah, that's a little bit about how to select different values from a data frame you create. So I'm gonna talk a little bit about conditional selection. So let's bring up our data frame again. So this is the data frame we were working with. So if we type something like df larger than 0, we can kind of see all the values where where they're larger than 0. So if it's true, it's larger than 0. If it's false, it's smaller than 0. And we can even specify different columns for that. So here I put W is larger than 0. So it shows all the values where the column W is larger than 0. So if we bring it up again, we can see that, yeah, it matches what we have. If you wanted to see the whole data frame, but only for the value specified, then you can put the condition inside its own brackets and like this and call it. So then we would get all the values where W is larger than 0. So if you look back at our original data frame, on the column, on the W column, only the value for row A and D is larger than 0. So here that's what we get. And you can do the same thing, but if I've added y at the end to the Y column, it would show the values for column Y only. So here you can see that it matches. Or you can kind of specify more to show 2 columns together. So there you go. And you can do different conditions, like using AND. So here I have the data frame where the column W is larger than 0 and X is larger than 0. So when we do that, then we get the same rows as above, because those are the values where W and X are larger than 0. So all the other rows don't meet that requirement. So now I'm going to talk about missing data. What do you do if you have missing data? So here is another way to create a data frame. So if you use pd.dataframe and specify your values and your index names in the dictionary, you can create a new data frame. So here, let's just see what that looks like. So here I have column A, B, and C with some values and some NaN values. So the NaN values are like the missing data. So what can you do to get rid of those? So what you can do is use drop NA, and it'll get rid of the rows with where NaN values are existing. And like earlier, if you specify access equals 1, that works on the column side. So then it gets rid of column A and B because only column C doesn't have any NaN values. You wanted to fill in those NaN values with the value. So you can use fill NA and specify value equals 0. So let's see what that looks like. Then you get, yeah, so in the original data frame, all the NaN values became 0 because I specified value equals 0. Or you can do other ways, like make it the sum of the column A. So here, where this value originally was NaN, it's now going to be the sum of column A because I'm using dot sum. So here we get 1, 2, and 3. Next, I'm going to show you how to use group by. So if I create a new data frame here and show what that looks like, you get, so here there's some identical values here. So some Google, Microsoft, Facebook with different people and sales numbers. So with group by, we can group those duplicate values. So using group by, if I type in group by with the company column and specify that we want to look for the mean, can do that. And it'll give you the mean for the mean of these two values for each company. You can do that for minimum. So it shows you the minimum value between the two sales numbers. Or you can use something like .count to see how many values of each company there is. So there's a lot of different other things you can use. So be sure to explore around and find out what works best for you. Here, I'm going to show you concatenating data frames. So I'm creating three new data frames here. So like above, I've put the data and the column names into a dictionary to create the data frame, and you specify pd.dataframe to make it into a Pandas data frame. So here, I'm going to bring up those data frames I've created. So yeah, there's three different data frames, and now I'm going to combine them together using pd.concat. So here I'm putting the three data frames in the brackets, and yeah, so they've all combined together into one data frame now. And here, I'm going to show you unique values. So I'm going to create a new data frame. And in this column, there's another duplicate. So there's two values that are 444. If I call .unique on column 2, then it only shows the different values, not the duplicate one. If I use nUnique, so it shows you that there's 3 unique values, which matches this. You can use something like value_counts to see how many of each value there is. So there's 2 444, then only one of these 2, and that matches. Yeah, and next I'm going to talk about applying functions to your data frame. So here I'm just creating a simple function. So that multiplies your argument by 2. So I'm going to do that with column 1. So column 1 is just 1, 2, 3, 4. So when I apply the function, yeah, so everything multiplied, all the values multiplied by 2. And you can use apply for not just functions, but here I'm putting length in. So it shows you the length of the values in column 3. So here they all have 3 letters, so that's the length, so 3. So yep. And here I'm just showing the sum of column 1. Yeah, 1, 2, 3, 4. The sum is 10. And let's just bring up the data frame here again. And if you use df.sort values and specify by column 2, it sorts it in order. So it'll put the numbers smallest to largest here. And yeah, you can also read files. So you can kind of have your own data frame in an Excel and a CSV file and read it into Pandas and display it onto Jupyter notebooks. So here you can do that by doing pd.read_CSV. So I have a simple CSV file created in the same folder where I have the Jupyter notebook. So if you do that, you can read it, and it shows it here. If your separate file is not in the same folder, you'll need to pass in the whole file path to access it. And yeah, you can read Excel as well. So you can do that by doing read_Excel and specifying the name of your Excel file name, and sheet name is just the tab. So I'm doing it for sheet 1. And I'm gonna read in my Excel file. So yeah, these were the values for my CSV file and an Excel file. So yeah, you can read in your own data and you can kind of play around with it using some of the things I've shown you earlier. Yeah, so for Seaborn, you have to import it like I did earlier. So I'm putting import Seaborn as SNS. So you don't have to use SNS, but that's the typical convention that people use. So I'm gonna follow that. And this line here, matplotlib inline makes it so that you can read the plots directly on Jupyter Notebook. So I'm gonna run that. And yeah, Seaborn actually comes with a lot of data sets you can play with. So here I'm going to load in one of their preset data sets. So if you write down load underscore data set, and the data set is called tips, I'm gonna put it into tips here. And then let's see what it looks like. Okay, so this is the tips data set from Seaborn. And I'm just gonna show you some simple ways to create easy plots using Seaborn. So I'm gonna skip that line for a sec. So if you wanted to bring up a distribution plot, you can use sns.distplot and specify that. Here I'm specifying that I want to show it for the total bills section. So I'm gonna bring that up. And here, yeah, so it's very easy to just bring up a plot that you can look at the data and easily analyze it. So here we see that the total bill, most people have paid around $20 for the total bill. And this SNS.set style I have kind of sets the style of your plots. So if you can change it to a lot of different things. So here, if I kind of set it to white and bring up the plot again, it kind of, those lines disappear. So I like white grid. So that's usually what I use. But there's a lot of different styles that you can Google and see which one you like the best. And here I'm doing the same thing, but you can use bins equals 30, which gives you more bars to look at. So if you want a more detailed look at your plot, you can do that. So here there's a lot more bars here. And another plot is a joint plot. So joint plot lets you match up two dist plots and compare them. So I put sns.jointplot and specify the x-axis to be total underscore bill and y-axis to be tip. And here you have to put which data set you're using. So I'm using my tips data set and specifying, and for kind, you can compare them using a scatter plot. So here, let's see what that looks like. Yeah, so we have the two dist plots here, the total bill dist plot and the tip distribution plot, and it's comparing them using this scatter plot. And we can, yeah, so if you look here, we can see that it makes sense because the higher your bill goes, the more tips you pay. So yeah, that makes sense. You can specify into another type of plot to compare with. So here I put in hex, so we get a hex plot. Okay, yeah, well, that looks pretty cool. And another plot I'm showing you, pair plot, lets you plot pairwise relationships across an entire data frame. So here you only have to specify your data set because it shows you every single plot based on the different columns you have. It's just taking a while to load. Okay, so yeah, here it shows you comparisons between all the different columns that I have. So not gonna talk too much about it. You guys can play around with it and kind of see how that works with your data. But you can kind of change what you're comparing to. So here I've specified hue to be sex, and the palette changes the color that you use. So if I do that, pretty slow. Okay, yeah, so that kind of, and there's a lot of different palettes as well. So you can kind of change it to what you think looks the best. So here, and because I've set the hue to compare the sex, so we can see the different comparisons between male and female. And yeah, of course, there's bar plots, which are pretty easy to read. So that lets you aggregate data off categories in your data by the mean. So here I brought up the tips data set again, and to bring up a bar plot, you just use sns.barplot and here I'm setting the x-axis to be comparing sex and y to be comparing the total bill. And of course, the data is tips again. Bring that up, and yeah, so here you can see the total bill that men paid were higher than female. That kind of makes sense, I guess. And count plot. You can do a count plot using .count plot. So for a count plot, you only have to pass in the x value, because we're only counting the number of occurrences. So here I'm using x equals sex and data equals tips. So yeah, from the data set, there's more occurrences of men paying the bill than female. So I guess that makes sense as well. Okay, yeah, and next I'll show you how to create a matrix plot. So you can use matrix plots to let you plot data as color encoded matrices. There's something you can do called .corr. So that's shows you pairwise correlations between your columns, your numerical value columns. So if I do that for my tips data set, I get this, which yeah, kind of gives you a comparison of how they relate to each other. So if I use this heat map for this matrix that I have, we can create our own heat map. And yeah, this just kind of compares it for these values. And again, you can use, this is similar to palette, about like I showed earlier. You can change the color, and if I here set annotation to true, then you can see the values for the heat map. So yeah, it changed the color and shows you the values from the correlation here. Not sure why some of these are cut off, but sorry. Yeah, so here I'm gonna bring up another Seaborn data set. So it's called flights. So I'm just gonna load that. So it shows you here. So here's the flights data set from Seaborn. And here I'm going to do flights.head. So what that does is it gives you the first 5 rows of your data set. So here I get the first 5 rows. So it's the same as this. And I'm gonna do correlation again. So it only gives us the numerical values like I showed for tips. So we have the year column and the passengers column. And you can create a matrix using a pivot table. So here I'm using .pivot underscore table and specifying the values I want, the passenger values, and index I'm using month, and the columns I want to use year. So here we get another pretty pivot table that looks a lot better than what we had earlier. And I can create a heat map with this. So the next cell, I've taken this whole line here and put it into a heat map. And yeah, we get a nice heat map here to help us analyze the data. And like above, you can always change the style of your map. So here I've used magma, and again, there's a lot of different styles you can use. And the line color to be white and the line width to be 1. So yeah, changing that, you change your heat map and it looks a lot better, I think. So yeah, that's my tutorial on how to get started with Pandas and Seaborn. Hopefully it was helpful to all of you. If you guys are new to data science, I think these are really good basic skills that will help you explore and learn more, where you can play around with your own data. And if you already knew this, hopefully it was a good refresher. If any of you have any questions about anything I talked about, you can always connect with me on LinkedIn and yeah, ask me questions. Thank you.
Cool, thanks, Oscar. It's really a nice and solid tutorial. So do we have more questions for Anton or Oscar? Feel free just to type it out in the chat or QA. And also, this is the last chance to type in your name for the draw. All right, I guess I'll consider that as a no. So, Rich, yeah, go ahead.
Well, I'll ask a question, Oscar. So, as you're kind of like, as a new entrant to the, data science and Python space, what have you found the best resources have been as you've been on your journey?
Yeah, so I started out mostly taking online courses. So of course, you have to kind of get a basic understanding of Python first. So initially, I learned using Codecademy. So they have a lot of free lessons that you can use to learn basics of Python. And then after that, I took this Coursera course. I think it was called I forgot what it was called. Learning. I think it was called LTP. So it was like learning Python fundamentals or something. If you search, it was a Coursera course from University of Toronto. So I think that was a good Python course because it kind of gave you a lot of basics on Python, but got into more detailed skills. And it was really good because it showed you how to write everything cleanly with good descriptions, so that like if other people look at your code, they know what you're talking about. So that was a good course. And then after that, I just took data science and machine learning course from Udemy. So there's a lot of really good Udemy courses that are pretty cheap. Like you can usually find them for like $15. So that can go a long way to teaching you basic data science and machine learning skills. And then after that, you just have to play, like work on your own projects and apply what you learn. So that's kind of where I am right now, trying to apply more of what I learned into my own projects to, because you really only learn when you apply it. And yeah, I think teaching is a good way to learn as well. So that's why I'm here. And thanks to Carson for inviting me to give this talk.
Yeah, exactly. Teaching is the best way to learn. So congratulations.
Yeah, thanks.
Anton, I actually have a question. So I saw that you guys use both Flask and Fast API. Is there a reason why you use both? And which one do you prefer or like?
I don't know, is Jules still on the call? Probably not.
Yeah.
Oh, yeah, he is. Yeah, you
maybe,
talk about it.
maybe I'll answer that one. So I
Sounds
think
good.
the majority of our system is using Flask right now for historical reasons. But as we watched Fast API kind of like show up and mature, we just like what we've been seeing, particularly its integration with Pydantic models, if you're familiar with that library. So as we're evolving the system and adding, I don't know, new services or new APIs, we're kind of transitioning to Fast API.
Cool.
Yeah,
How do you like it?
I think the Pydantic part is really important actually, because that's kind of the foundation of the Fast API. And I'll keep the some words to myself, but the obscene words. But we basically very widely use Pydantic for like a lot of things, and really good reason for it is kind of imposing this strict sort of typing on like the inputs and outputs, but also really the clarity of the output messages if you do something wrong. So Pydantic for debugging has been like a pleasure to deal with, honestly.
Yeah, nice. Also, just wondering, like for your modeling, do you use like more of a traditional approach or deep learning?
So that is a good question. I was hoping somebody could ask that a lot earlier, because that's what I would ask to myself. In the world of deep learning, why are you not using deep learning?
Exactly.
The answer is that, so when you think about it, deep learning actually, requires quite a bit of data, right? Unless it's pre-trained on something very, very similar. So what we deal with is a new installation. So like, what are you going to train on when you just deploy the system, right? So essentially, we don't have the richness of the data yet, but because our contracts are like 10 years, at some point we will start switching when we gather enough data. But at this point, essentially the answer is no. But through Payson, we work with students. So we have some golf students. We also have some graduate students from U of C software engineering master's program. And so those guys, we actually have 3 of them working with us on a project. And what they're looking at is essentially how to evolve models over time. So when you have only, a week worth of data, what kind of model should you use? And then when that week of data turns into 2 weeks, should you switch a model or should you stay? And then, this kind of like evolution in time of models. So that's what they're dealing with. And so, yeah, that's kind of the answer.
Nice. Yeah, I also have some IoT experience myself, and also play around with the deep learning models and also the traditional models. And I found like the LSTM and the sequence-to-sequence models work particularly well for some of the models, but they don't always work well. So just like check if you guys use any of the deep learning as well.
Yeah, that's kind of one of the plans, is to figure out, like we tested them, right? It would be kind of silly not to. But it's just, they can't beat certain kind of like fine-tuned and like smart feature generated normal models, like
Totally,
the
yeah.
non-deep learning models. But
Yeah.
in most cases, this is referred to as a cold start forecasting. So when you have little data, but you're still required to produce a forecast. And I'll tell you what, like for a good while, as in like a week, maybe a week and a half, your best guess as to what happens tomorrow is exactly what happens in the past 24 hours.
Yeah, that makes perfect sense.
Because there's not much to learn from to begin with.
My last question is, I noticed that for one of the tough questions you guys are facing is the connectivity. So what do you do with it?
Jules, you're muted.
Yeah, sorry about that. So that our response to that challenge is it's still evolving. We have in place the ability to check to see if our data has actually made it to the cloud, sort of in like a historical sense. We're always monitoring, like, are there gaps in our system? And if there are, we have provisions in place to kind of like roll through our history and fill gaps as required. So that's like our safety net, last resort catch-all sort of feature. And like, if data got dropped, maybe an hour from now we'll get it again. We're in the process of, because like our LTE connections, it's not everywhere yet, but I mean it exists enough that we do have to deal with it. So we built that safety net first, and now we're taking closer looks at, okay, how can we intelligently respond to, or detect and respond to changes in network throughput, and then that one's evolving at the moment.
Oh, sounds good. Thanks. Do we have more questions? That looks like it. Ben, do you have anything you want to announce or say or wrap up?
No, and my service is pretty spotty, so I got nothing to add.
Cool, awesome. So I'm gonna call it an end, and thank you all for coming. And special thanks go to Anton, Jules, and Oscar for giving these awesome presentations. And well, hope you guys all have a great summer, and I will see you guys again in September.